Sorry guys, I'm not too good with holding mics. I also talk excessively loud in my experience as a teacher at some point. So I will stick without the handheld mic for now. I will also try my best to leave some room for questions, since this is kind of somewhere between a general and a technical topic, and very curious to continue exploring and see if anyone has any additional directions to consider. I've probably spent about 1.5 years so far on this project, but so sometimes I get a little too deep in one direction and kind of forget to back out and take a more general approach. So without further ado, my name is Jessy Ayala. I'm actually from Southern California. Right now I'm a PhD student at UC Irvine, if anyone's familiar with SoCal. But beautiful city here in Austin so far. Before I get started, I like to have a raise of hands. Anyone who's had an overnight layover in an airport? All right, keep those hands up. How about during the overnight layover, you hear an emergency broadcast saying, can I have your attention, please? There is an emergency, and go to your nearest emergency exit because there is some kind of threat. All right, I guess I'm the only one here. I see one over there.
It was a fire.
I actually was not sure what exactly the threat was, but it was kind of scary considering it was 3 a.m. and I've never been to Texas before, but afterwards it's been a very pleasant trip.
It's a safe space. We do not let guns in the airport. Okay. Yes, sir.
Right. Not an April Fool's joke. It was definitely real. Unfortunately, it was not an April Fool's joke. Anyways, so this presentation will be exploring socio-technical security concerns in critical open source Python repositories. You'll see that most of the presentation actually talks about 3D printers, but you'll rest be assured all of the repositories that I've looked at so far are indeed Python based. But before we get into the meat of the talk, I just wanted to give a brief overview of pull requests and their power in open source projects. So we defined the sequence of introducing new code as an open source contributor. You create a fork of some repository, which just means you make a copy for your own repo for development. You make some code changes. Perhaps it's a new feature, perhaps it's a bug fix, perhaps it's a typo. You submit a pull request in which a project maintainer from the main repository will review. They approve or disapprove that pull request, from which forward will be preferred as a PR, because I'm going to say PR a lot. And hopefully that new code is merged into the main branch or some kind of development branch, depending on what type of repository we're looking at. And who here has an academic background or has done some kind of research / sometimes read papers? Anybody here? I see a few folks here. Has anyone heard of this paper recent from University of Minnesota? Yep, 1, 2, 3, 4. So for those of us who aren't familiar with this controversial paper, there were some folks at the University of Minnesota that not only intentionally, but actually introduced some vulnerable code into the Linux open source project and wrote a paper about it, which made it to the acceptance process, but then got redacted after the reviewers realized that there is some kind of issue here. There is some ethical concerns. Maybe us security folks shouldn't actually introduce vulnerabilities in real-world software or projects without letting the maintainers at least know. I mean, these guys just introduced bad code into the Linux project, let it kind of sit there, and let the reviewers of Linux, spend the trouble of having to take that code out. They wasted time reviewing this code, but the moral of the story is it's unethical to introduce vulnerable code intentionally into any source of project, even if it's for research purposes. Hence, there are new ethics security workshops at security conferences now.
Doesn't that reveal, though, that there was a huge hole in the review process?
Right.
And that's a really good public service. There's nothing unethical about fixing the process at all.
That is very factual, with the addition that researchers should take some kind of ethical considerations, considering that I don't know how many people, I didn't Google a number beforehand, actually use Linux open source, or you have some kind of Linux software running, but it's just, there should be different ways. There's the argument of, hey, I'm doing this for the greater good, but what is the boundary? You know, it's a little fuzzy still, hence like why there's so many now research papers focusing on ethics and security projects. But circling back here, are there vulnerabilities in 3D printing repositories?
Yes.
There probably is, right? I mean, you could go on your CVE database search. I'm sure if you look up 3D printing, there'll be a lot of results that come up. But the gist here is there's a bunch of repositories. A lot are written in Python and C/C++. And we kind of just want to explore how secure are these 3D printing repositories, because the market for 3D printers, just in case you did not know, is growing at an exponential rate and becoming highly dependent upon. So this is why we tend to focus on projects, specifically 3D printing from a bag of tricks. So these are critical open source supply chain security repositories. More specifically, if we want to look at this from an ethical perspective, one way to consider not doing so is actually submitting pull requests that have vulnerable code. So our approach is just looking at the history of repositories. We're taking a look at pull requests, for instance, that have already been merged into the main code base. You know, some of these repositories date back to 2012, some of them date back to 2020, some of them have just recently came out. So our question is, which pull requests can we trust? Here's an example of a PR that's simply fixing typos. Someone noticed that there, for instance, let's see, what do we have here? A cross with 2 C's turned to an across with 1 C. Okay, pretty innocent pull request. A pull request to change the fan speed or record the fan speed of a 3D printer, for instance. But, you know, there are some attack vectors that we could think of on the top of our head maybe. I've had some time to brainstorm, so an example can be overheating or unintentionally printing out objects that the user would not want to print out. So if someone could remotely log into someone's 3D printer, they can use that and take advantage to print out whatever they want. They could overheat some stuff. Perhaps it's just a pain to buy materials and someone just goes through all your materials and you can't use your printer anymore because you have to go buy new materials for it to work. But at the end of the day, we have a few research goals. Because this is a research-oriented approach, we are looking at governance structures in pull requests, in open source projects. We are looking at, in other words, who has the power to approve pull requests? Who are these people approving pull requests? Do they have a security background? And they're merging hundreds of pull requests, which in itself could be a security concern, which I'll talk about eventually. But in other words, too, do pull requests actually introduce new vulnerabilities? For this first part of the talk, we will focus on those first 2 research questions, talking about governance structures, which I'll define in a minute, and who has the power to approve pull requests. I know there's a lot of text here. Our approach is essentially, we want to measure and quantify potential security concerns in open source repositories from what we would call a socio-technical perspective, which means we are not writing code to introduce vulnerabilities. We're not writing code to exploit vulnerabilities. We're simply taking a look at the landscape of 3D printing repositories, and I'll actually talk about overall top Python repositories, to see if there are any security risks. We do this by taking a look at repositories related to 3D printers, since that's our case study. And for each repository, we look at metrics such as the number of pull requests, the number of pull request creators and mergers, so who are the contributors, who are the maintainers, the number of conversations that are happening. You know, for instance, I think we could argue that if something is security related, we should at least be talking about the code before it's merged. Like, is the bug fix introducing new bugs? Is the bug fix actually going to work, etc.? Is the vulnerability actually being patched? Are some of the things that we're concerned about. We want to apply pull requests that are security related. We do this through some kind of basic keyword search. We plan to introduce some type of machine learning to see if conversations are actually about security versus we found a few pull requests that we thought were security related. It was just talking about job security. So, you know, getting the context of conversations is actually a little more tricky than you think, especially coming from a non-machine learning background. Taking the context, and as we saw in the last presentation too, machine learning is something that we should be able to trust. And looking at the context of conversations would obviously be a very helpful metric, as opposed to digging through 1,000, maybe there's only 20 security actually related pull requests. Last but not least, we want to take a look at how long between submitting a pull request versus it actually being included in the main code base, because ideally you'd want a security related pull request, which right here, this bottom one, look at the difference. This took 113 hours to merge, which I think by my very quick math is about 4.5 days, maybe even close to 5, as opposed to very not related pull requests that took only just over an hour to merge. Maybe they just checked it. We want security related pull requests to be thoroughly reviewed, is what I'm trying to say. So here's an example from the Octoprint plugins repo, which is a very popular 3D printing repository project. This is just to give you an idea of, you know, behind the scenes, what is the data that we're collecting, and what is the data that we're applying, for instance, machine learning to. Again, transparency, as mentioned in the last presentation, is very crucial for reproducibility, replicability, and all those other words that I can't pronounce. So here is just for instance, we could see who created the pull request, who actually merged the pull request, if there was some kind of conversation, we could see the number of comments, and you know, how just general information that could be useful for our research questions. Yes?
If I'm attacking these sites, don't I want to push out fixes such that they don't appear to be like security addressing issues? In other words, I want to sneak my bad actor code through the door that no one's looking at.
Right, that's a great...
You're looking at the door that everyone's looking at to see exploits and attempts to fix those things. So you're not going to actually find the bad actor.
Right, it's an interesting point that you bring up, because to my knowledge, there are 3 main threats against open security, and the number one is malicious actors submitting bad commits, whether that is not masked as a bad commit, or in the more realistic case, it's looked to make it seem like it's not actually a bad pull request. You know, maybe it's one of those where they fix 100 files and you go in your GitHub viewer, you can't really see it, and you're like kind of lazy, and you're like, okay, maybe I'll just, you know, merge this. But there's actually some bad code in that, which I'll get to in our second part of the presentation, where we're actually trying to use static analysis tools to hopefully identify those pull requests that introduce bad code. Or in other words, what we care about more is vulnerable code. So that's a great point you bring up, because that is definitely true. Stealthy commits, if you look up stealthy commits, I'm sure I think there's about 5 papers that talk about this very issue. And some preliminary statistics, again, just for transparency. You know, I love that the previous presentation kept, you know, kind of, hey guys, we should be transparent about our data, and we should make it open source. I'm all for that. So here are some repositories that come from the first 9 pages. But these are the top 15 repositories that have the most merged pull requests, i.e. pull requests that are included in the main code base. So, I mean, we have a very large range of statistics here, including, look, like the first one, you have 957 unique authors. There are 7,500 merged pull requests, but there are actually 22 mergers. So this seems like a pretty large team For instance, if you go down maybe to the Kevin O'Connor Clipper project, which is also a very popular 3D printing open source project, we only have one merger, there's 207 unique authors, and there's just over 500 merged pull requests. So again, putting on my security hat, I would hope this person has some type of security background or security, even awareness, or some workflow in place to check for bugs that before merging all of these pull requests from a wide range of contributors, which is exactly what our next guy here is talking about. This is just we use some keywords. There's just an example of some of the keywords that we use to identify potentially security-related pull requests. We have exploit, vulnerable, attack, unsafe, vulnerability, and security. So there's more, but this is just a little snippet, just for anyone who's curious of how we call a PR security-related. So let's talk about governance structures. Governance structures, what we define to be were democracy versus autocracy. We would call this one, for instance, to be more of a democracy where there's somewhat of a balanced range of project maintainers on this side here. This would be my right-hand side. While on this one over here, if I'm facing this way, would be the left-hand side. We have this project maintainer named ThinkyHead, who just in 2021 merged over 600 pull requests. And you can see from 2018 to all the way to 2020, ThinkyHead merged over 1,000 pull requests in a given year. Let me say that one more time. One person is merging over 1,000 pull requests in a single year for 3 years consecutively. And going back in time, you can see 2016, they merged just about 1,000. But again, this would be an example of what we would call an autocracy. One person kind of seems like they're in charge. And again, we would hope this person has some kind of security background, for instance, or that they're actually thoroughly reviewing these pull requests. And again, some more autocracies that we are addressing. Again, I also give some statistics of how popular these repositories are. There's the Clipper project that I mentioned earlier, Kevin O'Connor, which is the username, seems to be merging every single pull request. No team, this guy is just merging everything, right? And even in this project, Repository firmware, this is a 3D printing firmware project. We have our user Repository merging every single pull request. And I'm sure if I could go back a couple slides, you'll see there are a wide range of contributors. This is just, again, this is a socio-technical perspective. We are looking at the human-centered security perspective, which, if you look into it, is very underexplored, especially in the context of open source project. And I think it was something like 97% of cyber attacks have some kind of human in the middle, whether it's phishing or something else. So we are concerned of the safety of open source projects. And of course, there are some repos with limited activity. This person only merged a total of 6 pull requests in 3 years. Oh, this person only merged 1 pull request. Are they making commits on their own and making the project run? Is there an old vulnerability that hasn't been patched in this popular repository? Over almost 1,300 stars. You know, it's just, it's something to think about. It's something to ponder. Who is using outdated repositories? Who's using the Creality 3D printer, but hasn't really checked that there's any CVEs? It's hard to see behind the scenes to what extent users are updating their software. I feel like there's a large reliance on open source and trust in open source because of the transparency aspect, but it's just concerning. And I see a hand up over here again.
You mentioned a couple of times that you worry about the committers having security expertise, and in 3D printing, I can't imagine that any of them have security expertise. In fact, the security community tells all of us to not develop security expertise, to leave that to the experts. So I'm confused why you think that anyone would ever be able to find any security problem in any of this community.
Right. I love that you bring that up too, because I mean, as someone who took a security route, I didn't start actually learning about security until I was interested in security. So it is indeed a concern, which I'll mention in a bit. GitHub has some automatic security features that you could easily implement, I think, with 3 clicks, that a lot of repositories don't actually use, that maintainers can take advantage of. So to that point, we will actually be looking at the extent in which top open source projects actually use this automated security features to begin with on GitHub. And again, that is a really great point. A lot of developers, it has nothing to do with the developers. I guess you could kind of argue that if they went to some type of post-secondary education, that there should be security content included, but that is a whole nother issue on its own, and which is why we hope to raise this. Another goal you could argue is we want to raise awareness that, hey, there are some automated features, let's implement them. It's okay if you're not security backgrounded or have some security background, but it would be really nice to point out that these are open source projects. Hopefully people that are using open source projects, there's at least a few folks that would be concerned about the security and submit some kind of pull request, or you get that depend upon pull request from GitHub and you say, hey, there is a critical concern in your repository. Please merge this pull request so then this library, for instance, is upgraded to the most recent version, so your users are securely intact with your pull request. So thank you for bringing that up. That is a very transparent issue that I think it is barely the second year that we have a security education related workshop at the top security conferences.
So 2 slides back, you were showing democracy versus democracy. It was more firmware. Now, what I didn't hear you talk about is kind of complexity bucket. If you've got C code that's got inline assembly, I want it to talk. Probably actually be a person who's an expert. If you've got a democracy that's just standard Java or Python, whatever, there's probably a greater community side that can handle the
Yeah, I mean, in software engineering in general, I know at the top software engineering conferences, they are recently exploring identifying expertise, for instance, in open source projects or in companies in general. That is a great point you bring up, that perhaps there should be experts. Perhaps in a autocracy it would make more sense for something that's bash-centered or something assembly-centered, but maybe it makes more sense for a popular language to have a democracy versus an autocracy. So that is something to think about. I guess I appreciate that perspective, because now that's something that's going to stay in the back of my mind after this talk, that hopefully I can go back and address with the team, and maybe that's something to look into, to consider. Thank you for that. And to start moving away from 3D printing to the overall top Python repositories, I just wanted to give you a glimpse of the Django project versus the Yellow version 5 project, which I think is a machine learning project oriented. So you can see in Django, it seems to be democracy oriented, where there's a good amount of project maintainers, but really there's a shift. If you see back in 2012, all the way up to 2018, there's this maintainer, Tim Graham, that seems to be in charge, we'll call it in charge of the project. While there is a shift to this new maintainer, Felix, 2X's M, from 2019 all the way to this year, which is he or she has already merged more than 100 pull requests this year alone. So it's just, again, an interesting perspective. Perhaps this is something to look into. And again, to raise the awareness, we should have some type of code scanning tool in place, which I'm going to get to, or hopefully this person has some kind of security background. And going down to Yellow version 5, we have this one project maintainer, mostly one project maintainer, Glenn Joker, who seems to be taking charge of this project, and to this day has merged just about 2,000 pull requests alone. So again, just something to ponder. this is an initial kind of like approach of assessing the landscape that can hopefully open up some new research directions. So this is an example of a thinky head in that other project that we saw. This person merged a bunch of pull requests. This is a suspicious merge example where, sorry, this was merged before I had a chance to review it. I'll make sure that all admins are brought up to date in the no merge policy ASAP. So this is an instance where perhaps vulnerable code could have been introduced that we were able to identify. But again, there's a lot of stuff hidden in the deep waters. It's almost like finding a needle in a haystack. And last but not least, to wrap things up, I'm going to have a group of slides talking about if pull requests actually introduce new vulnerabilities. Like I mentioned earlier, GitHub has a tool. This tool is CodeQL, if we've heard of it before. They can automatically scan your code with the click of 3 buttons. You get a GitHub workflow set up for you, depending on what language you're using, assuming your repository is CodeQL supported, which Python has a bunch of queries where they can actually find potential security vulnerabilities. So after like randomly selecting some pull requests from this specific repository called the Spaghetti Detective, again a 3D printer, there was one that seemed to have an unbound local error. This is very tricky to find a needle in a haystack. Even if this isn't directly security related, it is something to consider, and hopefully, fingers crossed, we do, not fingers crossed that we find stuff, maybe fingers crossed that we don't find stuff. So we plan to continue running static analysis on a bunch of different pull requests. Looking at the top overall Python repositories, which is what I really wanted to get to, based on the top 100, we found that just over 1,000 were potentially security related pull requests. 28.3% of these have a security policy in place. The reason this is a weird number is because we only looked at repositories that have at least 50 merge pull requests, and I think that number was 71, so hence the weird percentage, even though I'm saying it's out of 100. And however, only 10% of top Python repositories, looking at all of them, have some kind of CodeQL workflow enabled or code scanning enabled. So out of the top Python repositories, looking at the top 100, in this case it would be 10. This is from a paper that it's going to be published at one of the top software engineering conferences coming up, one of their co-located workshops on software vulnerability management. This is something to be concerned about, for instance, back to our point where perhaps not a lot of people don't have a security background. But CodeQL, please enable it if you are in a top Python repository or some kind of open source repository. This will give you notifications to merge your stuff. At the end of the day, this number should be higher. I'm just glad to see that at least 75% of them have at least one type of workflow enabled, perhaps for template checks. Or maybe it is a security check and it's not specifically CodeQL, we just didn't find that. But there is progress to be made in having automated security scanning in top projects in general. If you're curious, Kotlin, 1.7% of the top projects have this enabled. That is also very concerning. But to focus on Python, it's 10%. Yes?
In addition to your top Python repositories based on your GitHub analysis, but we've also looked, PyPy will mark packages as critical.
Oh, okay.
So that will be another thing to look close at. Even if you don't have the little activity, it'll be top. The things that key to, frameworks, build systems, and so forth that are fundamental for Git, for utilities. So PyPy marks are critical.
Gotcha. Thank you for bringing that up. Yeah, I mean, dependencies is, that's a whole nother topic. Supply chain dependencies, if you SigStore, all of that stuff. Some folks that came out of Google are also developing all these really nice tools that hopefully will help supply chain security in Python specifically to be more secure. Yeah, dependencies are a huge topic to consider. and just to kind of look out for. So at the end of the day, we talked about governance, we talked about vulnerabilities and pull requests, specifically looking at CodeQL. Next steps are to investigate PRs that are actually security related and to see if there's actually a relationship between CodeQL security findings and governance structures. So is it really the case that there's too many eyes on this project or that there's not enough eyes on this project? I doubt we'll find some kind of correlation, but hopefully at the end of the day, we just want to hope that all our open source projects are secure since a bunch of people use them. And I'm glad that you asked questions throughout so that I didn't have to leave too much time at the end. Thank you.